Welcome viewers, moving on to exercise 6.3 of class 8 mathematics, squares and square root. Question number 1. What could be the possible ones digit of the square root of each of the following numbers? Square root is operative inverse of square. So this number has been obtained by multiplying square root of this number to itself. So while multiplying two numbers, the unit digit will be determined by unit digit of both the numbers. It won't be affected by the tens or hundreds or further digit of the number. So the unit digit of this number is 1. So in which situation can we get unit digit of two numbers multiplying to itself? So we can have 1 multiplied to 1. In that case we'll get 1 in unit position, or we can have 9 into 9, that is 81. In that case also the unit digit will be 1. Clear? So there are two possibilities only. The unit digit of the square root of this number can be either 1 or 9. Clear? So 1 and 9 are two possibilities. 6 is the unit digit of the square. 4 into 4, 16. So in that situation we can have 6 in the unit position of the square, where square root multiplied has got 4 in the unit position. Similarly 6 into 6, 36. So in this situation we can have 6 in the unit position. So two possibilities are 4 and 6. Clear? Again 1, so two possibilities are 1 and 9. 5 in the unit position, only digit when multiplied to itself. Yes, 5 is 5 into 5, that is 25. So we'll have this 5 in the unit position. So the possibility is 5 in the unit position. None other number when multiplied in itself will have 5 in the unit position. Clear? Question number 2. Without doing any calculation, find the numbers which are surely not perfect square. We have already learned number ending with 2, 3, 7, 8 and with odd number of zeros cannot be a perfect square. Number ends with 3. So this number cannot be a perfect square. Number ends with 7. Again, this number cannot be a perfect square. Number ends with 8. So again, this number cannot be a perfect square. Number ends with 1. So this number can be a perfect square. Probability of 21. Clear? Question number 3. Find the square roots of 100 and 169 by method of repeated subtraction. We have already learned that if n is a natural number, then n square is equal to sum of first n odd natural number. So 1 plus 3 plus 5 and plus so on till the nth number. So the nth number will be the last odd number, and from 1 to the nth number, when you add, we get n square. So in this case we have got value of n square as 100. Now if we keep subtracting 1, then 3, then 5 and so on, from moving from right to left hand side, we'll be left out with 0, and in that case the last number to be subtracted will be the nth number. So we'll get the value of n. So we start 100 minus 1 is equal to 99. We again subtract the second odd number, that is from 99 we'll subtract 3, we'll get 96. From 96 we'll subtract 5, we'll get 91. From 91 subtract 7, so we'll get 84. 84 minus 9 is equal to 75. 75 minus 11 will be 4 and this will be 64. 64 minus 13 will be 51. 51 minus 15 will be 36. 36 minus 17 will be 19, and 19 minus 19 will be 0. So we expect n in this case to be the 19th number. Clear? So let's count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 is the nth number. So we have got n as 10. So n square will be 10 into 10, that is 100. Clear? I have already subtracted the odd numbers one by one from 169. Let's count. This is 1, second, third subtraction, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So the nth number is the 13th number. So we get n is equal to 13. So n square will be equal to 13 into 13, that is 169. Clear? Question number 4. Find the square roots of the following numbers by prime factorization method. So we have to find square root of this number by prime factorization. That means we'll keep on dividing this number by prime numbers, and those numbers will be factor of this number. Let's proceed. So 729 can be divided by 3, which is a prime number. So we get here 2, 4, 3. Again we'll divide this by 3, we'll get 8 and 1. We'll divide this by 3 again, we'll get 2 and 7. We'll divide with 3 again, we'll get 9, again 3, we'll get 3, this 3, again by 3, remainder finally 1. So what we actually have done is that we have find the prime factors of this number. Clear? 3, 3, 3, these are all prime factors. Now we can write 729 is equal to all the factors multiplied together, that is 3 into 3 into 3 into 3 into 3 into 3. So here we have got these prime numbers in pair. Clear? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hence we can write this as 3 square into 3 square into 3 square. We can again write this as 3 into 3 into 3 whole square. So we get value 729 is equal to 3 into 3 into 3, that is 27 square. Now we want square root of this number. So if we move this square to this side of equal to, there will be change in operation and we'll get square root of 729, and that will be equal to 27. Clear? We have found the prime factors of the number. They all were in pair. We converted them into squares of those numbers, and finally we have done the operative inverse of square, that is square root, and got the result. Clear? Same way 400. Let's apply the same method. 2 again is a prime number, so we get here 200. Again by prime number 2 we get 100. Again by 2 we get 50. Again by 2 we get 25. We divide 25 by 5, which is again a prime number, we get 5, and finally we divide by 5, we get remainder 1. And we have obtained the prime factors of number 400. So again we can write 400 is equal to 2 into 2 into 2 into 2 into 5 into 5. And they are all in pairs, so we convert them into small squares. So 2 square into 2 square into 5 square, and we write this as 2 into 2 into 5 whole square, and we get the value as 20 square. So 400 is equal to 20 square. Square move to this side, and operative inverse of square is square root of 400 is equal to 20. That is what has been asked in the question. Clear? Moving on, in order to save time, I have already found the factors of this number. Let's find the answer. So, as you can see, 2, 3, 7, they are all prime numbers. So, we have derived the prime factors. So, we can write this 1764 is equal to 2 into 2 into 3 into 3 into 7 into 7. So, we get it as 2 square into 3 square into 7 square. This is equal to 2 into 3 into 7 whole square. This is equal to 42. 6 7s are 42 whole square, and under root of 1764 is equal to 42. Clear? Here we get 4096 is equal to, this is 2 square, 2 square, 2 square, 2 square, 2 square, and 2 square. So 1, 2, 3, 4, 5, 6. So we can write this as, this is equal to 2 square into 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 2 square, and this equals to 2 into 2 into 2 into 2 into 2 into 2, 1, 2, 3, 4, 5, 6 whole square, and this is 2 to the 4, 4 to the 8 to the 16 into 2, 32 into 2, 64 whole square, and we get the under root 4096 is equal to 64. Clear? In this case, we get 7744 is equal to 11 square into 2 square into 2 square into 2 square. So we get this as 11 into 2 into 2 into 2 whole square is equal to 2 into 2, 4 into 8, and this is 88 whole square. So under root of 7744 is equal to 88. Clear? Solving this, we get 9604 is equal to, this we get 2 square into 7 square into 7 square. Hence, this is equal to 2 into 7 whole square. Hence, under root 9604 is equal to 49 into 2, that is 98. Clear? So we can write 5929 is equal to 7 square into 11 square. So 7 into 11 whole square, that means 5929 is equal to 77 whole square. Operative inverse, so this is under root of 5929 is equal to 77. Okay. Here we have got 9216 is equal to 3 square into 2 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 square. 1, 2, 3, 4, 5 and 6th one. So 1, 2, 3, 4, 5. So we get this as 3 into 2 into 2 into 2 into 2 into 2. This is equal to 2, 4, 2 to 8 into 2, 16 into 2, 32, 32 into 3. That is 96. whole square. So we get 9216 under root is equal to 96. 529 is not divisible by any number smaller than 23. So we get the prime factors as this. We can write as 23 square, and under root of 529 is equal to 23. 8100 is equal to, you can divide it by 9 looking at it, but please don't do it because 9 is not a prime number. We have to find the prime factors. So this will be 3 square into 3 square into 2 square into 5 square. This is equal to 3 into 3 into 2 into 5 whole square. Hence 9 into 2, 18, 18, 5s are 90 square. So we get under root of 8100 is equal to 90. Clear? Question number 5. For each of the following numbers, find the smallest whole number by which it should be multiplied so that we get a perfect square number. Also find square root of the square number so obtained. So these are the numbers which are not perfect square. We have seen the perfect square has got prime factors which are in pair. We have divided 252 with prime numbers, and it is seen that 3 is in pair, 2 is in pair, but this 7 is not in pair. So if we multiply this number with 7, we will have another factor 7 to divide it to get n result 1, and the number so obtained will be a perfect square. Clear? So if we multiply 252 with 7, we'll get a perfect square. Clear? Now we have to find square root of this obtained number. So we can find by prime factorization method. So now of this number, 7 also is in pair. So square root of 252 into 7 will be equal to, let's see, we can write this number as 2 square into 3 square into 7 square, which is equal to 2 into 3 into 7 whole square. This is equal to 6 7s are 42 whole square. So square root of this number will be 42. Clear? The next one, same way, we have already derived the prime factor, but 3 is in pair, 2 is in pair, 5 is not in pair. So we'll multiply this with 5 and we'll obtain pair of 5 also. And the number so obtained will be a perfect square. So now the new number obtained will be 180 into 5. And we have to find square root of this number. So this 180 into 5 is equal to 3 square into 2 square into 5 square, that is 3 into 2 into 5 whole square, that is 30 square, and square root of 80 into 5, the new number obtained, will be equal to 30. Clear? So the number which will, the least number which if we multiply we will get a perfect square is 5, and the square root of the obtained number is 30. Same way here, if we multiply with this is in pair, this is in pair, this is in pair with 7, we will get another 7, and the number obtained will be 1008 into 7, and square root of this number will be whole square, that is 2 into 3 into 2 into 7 whole square, and this is 1008 into 7. Okay, so, and we obtain this 6 into 2 12, 12 7s are 84 whole square. So root of this, that is this one, is equal to 84. Clear? So if we multiply this number with 7, we'll get a perfect square number. Square root of that number will be 84. Clear? 2028 is also not a perfect square, so we have found the prime factors of this number, and here 2 is in pair, 13 is in pair, but 3 is not in pair. So if we multiply this number with 3, we'll get another 3 as factor, and this 3 will be again in pair, and the number obtained will be a perfect square. So the new number obtained will be 2028 into 3. So 3 is the factor by which if we multiply this number, we'll get a perfect square, and we have to find the square root of this number. So it will be, we can write this number is equal to 2 into 3, now in pair, into 13 whole square. So we get 13 6 are 78 whole square, and if we move on this square on the other side, this will be change in operation, and it will become a square root. The square root of the new number obtained is equal to 78. Clear? Now this one, here we see this 3 is in pair, this 3 is in pair, this 3 is in pair. So if we multiply this number with 2, we'll have another 2, and this will be in pair, these 2. And the new number obtained will be 1458 into 2. And let's find the square root of this number. So this number will be equal to 2 square into 333, 3 square into 3 square into 3 square. So we will be having this 2 into 3 into 3 into 3. So we have 3 into 3, 9 3s are 27, into 2 is 54 square. So square root of this number obtained, that is square root of this 1458 into 2 obtained, will be 54. Now this number, here again we have got these 2 in pair, these 2 in pair, these 2 in pair, these 2 in pair. 3 is not in pair, so multiply with factor 3 and get another factor here, which will be in pair. So we'll have the new number as 768 into 3, and we will get, this will be equal to 2 into 2 into 2 into 2 into 3 whole square, and this will be 2 into 2, 4 into 2, 8 into 1 2 3 4. I missed out a 2 here, so it will be here. So 2 into 2 into 2, 4 into 2 is 8 into 2, 16. 16 3s are 48, and this will be whole square. So square root of this number, the new one, that is 768 into 3, will be equal to 48. Clear? So in all these cases, we have multiplied with a smallest possible prime number, and we have obtained a perfect square. Clear? Question number 6. For each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also find square root of the square number so obtained. So in the previous case, we had multiplied the number so as to get a perfect square. This time we have to divide. These are the prime factors of this number. So here we see 2 is in pair, 3 is in pair, 7 is not in pair. So if we divide this number with a 7, so this factor will be gone, and the new number obtained will be 252 divided by 7, and we have to find the square root of this new number. So this 7 factor has gone, so we are left out with pair of 2 and 3. So we have this number equal to, this factor 7 is gone, so 2 square into 3 square. So we'll have 2 into 3 whole square, which is equal to 6 square, and square root of this number, 252 divided by 7 is the new number. Square root of this number will be equal to 6. So 7 is the number which, if we divide 252 with 7, we'll get a perfect square. Clear? In this case, we have got 13, which is not in pair, so we have to divide this number with 13 so as to get a perfect square, and we can write this number as 5 square into 3 square, these pairs, which will be equal to 15 square. Hence the square root of this new number obtained will be equal to 15. This one we are left out with 11, which is not in pair, So we'll divide 396 with 11 so as to get a perfect square, and this we can write as 3 square into 2 square, which is equal to 3 into 2, that is 6 whole square, and square root of this number by 11 is equal to 6. So 11 is the number which when divide 396 we get a perfect square. Clear? In this case we have got 23 in pair, so if we divide 2, 6, 4, 5 with 5 which is not in pair, we'll get a perfect square, and square root of this number will be, we can see, will be 23. Clear? In this case we have got 2 in pair, 2 in pair, 5 in pair, so 7 is not in pair, so you can divide this number with 7 to get a perfect square, and this can be written as 2 into 2 into 5 whole square, that means 20 whole square. So we'll get 2800 divided by 7, the new number obtained, under root is equal to 20. Clear? Here we have got 3 in pair, 3 in pair, 2 in pair, 5 not in pair, so we'll divide this number with 5 to get a perfect square. So the new number obtained will be 1620 divided by 5, and we can write this number as 3 into 3 into 2 whole square. So you get 9 into 2, that is 18 whole square. Hence under root of this new number obtained as 620 divided by 5 is equal to 18. Clear? Question number 7. The student of class 8 of a school donated 2,401 in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. So let's, the number of students in the class is x. They donated the same amount, that is x. So we'll get x into x, that is x square. This is equal to total amount, which is equal to 2401. So x will be equal to under root 2401. So let's factorize this 2401. So this number is divided by 7. So 7, 7, oh, sorry, and 7, 9, so again 7, 7, so we got the factors and these are in pair, so we can write x square is equal to 7 square into 7 square, or this will be 49 square. So x will be equal to 49, and what is x? X is the number of student and also the amount donated by each student. So there are 49 students in the class. Question number 8. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as number of rows. Find the number of rows and number of plants. So if the number of rows is x, it states that each row contains same number of plants. So the plants in each row will be x. If we multiply this, that is x square. This is equal to total number of plants. Clear? So we'll get x is equal to root of. So let's factorize this. 2025, 5, 4, 0, 5, again 5, 8, 1. We can take 9, 9, 9. Pair in pair. So we got x square. X square is equal to 2025 is equal to 5 into 9 whole square, that is 45 whole square. So x is equal to 45. So x is the number of rows and also x is the number of plants in each row. So both the parameters are 45. Clear? Question number 9. Find the smallest square number that is divisible by each of the numbers 4, 9 and 10. So I got 4, 9 and 10. We have to find the smallest square number which is divisible by these three. Let's first find smallest number which is divisible by this. For that we have to find the LCM. So we find the LCM of these three numbers. We take 2, 2, 9 and this will be 5. Again 2, 1, 9 and 5. This will be 3, 3, 5. This will be 3 and this will be 5 and this will be 5. Now we have found LCM, that is least common multiple. That means the least number which is divisible by all the three. So what is that number? We have got 2 into 2 into 3 into 3 into 5, which is equal to 2 into 2 4, 4 into 3 12, 12 into 3 36 and 36 into 5 is 180. So 180 is the LCM of these three numbers, which means this is the least common multiple or the smallest number which is divisible by these three, but it ends with single zero, so it cannot be a square number. So let's find a least square number which is divisible by these three. For that we use prime factorization method. So 180, we use 3 here, 6 0, 3 again, 2 0 and 2, this is 10, this is 2 again, this is 5. So 5 and this is 1. So we have got 3 in pair, 2 in pair, 5 not in pair. So suppose we multiply 180 into 5. Okay, so we'll multiply this 5 and again proceed with factorization and we'll get a 5 also in pair. Now this number has become a perfect square and this is the smallest possible number. Clear? Because we have used the prime factorization method and we have taken the smallest possible prime number which factorizes to 180. Clear? So let's find out what. So the number will be 180 into 5, that equals to 900. So the smallest square number that is divisible by 4, 9 and 10 will be 900. Clear? Question number 10. Find the smallest square number that is divisible by each of the numbers 8, 15 and 20. So we'll solve the same way. We'll first find the smallest number which is divisible by 8, 15 and 20 and then find the smallest square number which is divisible by these three. LCM of this number, let's start with 10, again 2, 5, so we get 2 into 2 4, 20, 40 and 40 into 3 120. So we have got 120 as LCM. That means this is the least number which is divisible by these three, ending with single zero, so this cannot be a square number. So let's convert this into a square number which is the smallest one. So we use prime factorization method. 120 start with 2, we get 60, again 2 we get 30, again we divide it by 2 we get 15, we divide it by 3 we get 5, we divide it by 5 we get 1. Here we see 2 is in pair, this 2 is not in pair, this 3 is not in pair, 5 is not in pair. So let us make this all this in pair. So we'll multiply here with 2, with 3 and with 5. and hence the number obtained will be 120 multiplied by 2, this 3 and this 5. This equals to 15, 30, 30 into 3 into 12, 30, 36. So 3600 is the smallest square number which is divisible by 8, 15 and 20. Clear? So this completes our exercise 6.3. Keep practicing.